Hello and welcome to D-Home Solar. I'm Stefan Arouet and I work in the design office. Today we're going to look at the Roof Solar flat roof system. The installation of these modules can be done either completely flat or at a gentle 10-degree incline. This training is intended for photovoltaic installers. We'll assume that the rails have already been welded between the layout and the installation of the modules. A second training is available online and it's intended for waterproofing specialists. We also cover the layout process and stop at the welding of the rails. Roof Solar is compatible with 3 types of waterproofing systems: bitumen and PVC systems with our partner EcoAxter, and TPO systems with our partner Allsim. I invite you to download the technical reports from our website. Don't forget to also download the installation manuals. They cover the installation of modules, both flat and at a 10-degree incline. We'll start with the layout, and at a minimum, 4 people will be needed. 1 person will read the cumulative codes on the plan. 1 person will do the marking, while the other 2 hold the measuring tape. We recommend using red chalk for marking. If you have to come back the next day, the marks won't be erased. If it's a project with a large number of modules, we create marking zones and then weld the rails afterwards. We don't mark everything and then come back 2 or 3 days later to weld, as the marks might be erased. Of course, for both marking and welding, you'll need a clean, dry membrane, and for bitumen as well. The outside temperature should be at least 2 degrees Celsius. For PVC and TPO, before marking, you obviously need to clean it thoroughly and make sure it's completely dry. Before starting the marking, there are a few checks to perform on your roof. Between the parapets and the ridge stops, and then compare with the plan that was provided to you. Are the skylights properly installed in their designated places? Then you can effectively start the marking process, as I previously mentioned earlier, with some dedicated people carefully holding the measuring tape, 1 individual diligently reading out the precise cumulative measurements, and another person accurately marking these cumulative measurements directly onto the ground. We'll use the plan provided, referencing point 1.0, to orient ourselves. We will draw a parallel line in relation to the long side of the roof terrace. As you mark the measurements, you will need to continuously check the spacing of the rails and the cumulative measurements indicated on the plan. A measurement that comes up regularly in our layouts is the 1040 measurement. It's actually a measurement we've used for all our module support tests, so you'll see it regularly in our layouts. Before commencing the installation of the rails, you need to meticulously mark out the area, starting by carefully drawing a precise rectangle, mot. On a specific area of the generator, we're not going to do everything, and if you look closely at my marking, we start right at the edge of a rail, so that's the famous parallel line we've drawn at the bottom of the generator. That's our rail, our starting rail, and we're not doing the entire top of the generator. We position ourselves just before the last row of rails. So when you're marking out a rail to rail, like here with this measurement we see on the screen of 9.74 meters, you need to make sure to mark beyond the indicated measurements so you can properly position the rails afterwards. But in any case, we start with a bare roof. You have your plans with you. Here, I've shown the roof dimensions in the background. So we start at point 0. If indicated on our plans at 2 meters 26 and 1 meter 12 to 1 meter 13, we will draw our first parallel, like here on the right in the photo, in relation to the ridge. We make several points at 1 meter 12 to 1 meter 13. We're more or less parallel. What we can do now is draw our perpendiculars on the first column and the last column, which will be around 15 meters. And for that, we use the 3, 4, 5 method. So starting from point 0, we make a mark at 3 meters. We draw an arc from point 0 at 4 meters, perpendicular to our first line. And we measure the distance between our 4-meter arc and our 3-meter point. And then we draw another arc. Now we can draw our first perpendicular, and we repeat the process on the left side. So we do our 3, 4, 5 again with our arc intersection at 5 meters between the 3 and 4 meters. Our 3-meter pair and our 4-meter pair, and we draw our perpendicular. On these two lines, we can already mark our bad rail pair at 9.14 meters on each perpendicular. And before going any further, what you should do is check your diagonals. Between this point here and that point there, you will have a distance. And between this specific point located here, which we are currently observing, and that distinct point situated over there, which marks the other end of our consideration, well, we can clearly see a significant and interesting relationship developing. You should always have precisely the same distance between them. Cool. If you have a difference of 3 or 4 centimeters between the two diagonals, that means there's a mistake in your layout. If everything is correct, then you can draw your last parallel line. I prefer the red lock with the blue methylene humidity, which tends to be quite easy, whereas the red Charister lock. So once you have drawn your entire generator outline here, you can start on your cumulative dimensions. And this is where you really need to have about 4 people, 2 to hold, let's say, the 20-meter tape, 1 person to read the cumulative dimensions, and someone to mark on the ground. So you start with your 1040, here you're nicely positioned between 2 rulers. Here, the other dimension. So this is a somewhat special measurement that will be indicated on your plans anyway. But if you look closely at 1742 and 2782, well, you get 1040. And you continue all the way like that, and so on. You go across, draw your cumulative measurements. They are facing each other. You move to the perpendicular and do the same, using the cumulative measurements indicated on your plans, and you do each side. And then all you have to do is draw. Usually, there are 3 of you to do the marking, meaning you draw your first straight line, so you go much further than your markers. Don't hesitate to go well beyond the markers. There are those who stretch the chalk line, and 1 person stands in the middle to press the chalk line to the ground on each side. And you go all the way to the end like this, and then you do the same thing in the other direction. Again, there are always at least 3 people. Of course, here I drew the line going over the sky dome, but that's not how it actually works. In reality, you have to redo your perpendicular at 8.71 meters, as indicated on the plan here. When there's a sky dome, you might have to start over several times. And once you've marked everything out, all that's left is to prepare your rails. There you go. You see your first reference for the bottom of the rail, and each time you're working from the bottom of the rail. In fact, you're only marking one side of the rail, and so on, and you can install the rails. So this is more the part for the waterproofers, which you'll be able to see in the next video. Here we'll assume that we've finished marking everything out, and now the waterproofers just have to weld the rails. Of course, for marking out, if you have very large sites, I recommend using a laser or a total station for this initial marking. 1 person is enough. The components of the roof solar system for flat modules. 2 types of fasteners. The intermodule fastener, a universal fastener equipped with its clip to ground the module frame. If you have 2 rails under the module, always choose the outer side. It clips onto the rail. Here I'm showing you an exterior fastener, a universal intermodule fastener, exterior fastener on the outer side of the rail. Your modules are always in the middle of a 60 centimeter rail, so roughly at 30. And your rail goes like this or like this. You have the exterior fastener here. Obviously, if you had a second module here, we would start at its position, and here you would have a universal fastener, not an exterior fastener. The CTR, which stands for Central Tensioning Rail, can be effectively utilized together with the exterior fastener, a standard 3 mm Allen key, carefully inserted into the exterior fastener, always ensuring you are properly inclined in the precise direction of the slope with your rail system. It's not strictly needed if you are positioned perpendicularly to the slope's gradient. However, it possesses another crucial function, effectively grounding the rails. This essential component is typically positioned at the very end of the rail section, and in actual practice, we invariably commence with this particular one for the vital purpose of grounding the entire system. The cable pass-through clips onto the rail, like this. This is usually the first one here in the notch. You use one per module. You can place them wherever you want, wherever you have more cables. It can help you bundle them together. And also for running the yellow-green wire 6 mm squared. We can also provide you with the part that holds an optimizer or a microinverter, the FIX 103. It clips on in the same way as our external mounts or our universal mounts for modules. It comes equipped with a 20 mm screw, 5 mm Allen key, and a washer. And you simply attach the optimizer or the microinverter like this. What you need to be careful about is maintaining a 1 centimeter air gap between the rail and the heatsink. Our three mounts here are securely tightened to 10 newtons, and the CTR is precisely between 2.5 and 3 Newton meters. Before installing the roof solar module system flat, you'll need to check a few measurements. The gap between two rails of 1040, which you can find on our various plans. If it has been maintained within plus or minus 1 centimeter, you need to check these gaps under each module. The other measurements will depend on the size of your module, but regardless of the module, this 1040 measurement under the modules is the same for every project. Also, before assembling the system, make sure that the PVC and TPO rails have been properly fitted with their patches underneath the rail and placed on the correct side. The patch, whether it's made of PVC or TPO material, meticulously measures 80 inches in length and precisely 60 inches in width. And it absolutely must be carefully placed on each and every side of the rail, specifically inside the base of the rail itself. This means, quite importantly, that it should not, under any circumstances, extend onto the various membranes that are firmly attached to the rail structure. The first thing, once you've made these checks, is to ground each rail, and this is done with the CTR. A set screw is specifically used to securely fasten the CTR component to the rail assembly, and it should be carefully tightened to a precise torque value, ranging between 2.5 and 3 newtons, ensuring a firm and stable connection. And you have the upper set screw, which is used to attach the green-yellow wire. When you tighten it, you need to stop well before it comes into contact with the aluminum of the CTR, because the copper could come into contact with the aluminum, and that is not allowed. Tighten from 0.5 to 3 newtons, whether it's for the small tab here on the rail or for the green-yellow wire, and at the crotch of 3. And this needs to be done on each rail. Once you have grounded your CTRs, you can do your wiring and equip the rails with the fastenings. Don't forget, as I mentioned earlier, for the lower generator CTR, if you're aligned with the slope at the level of the rails, you need to install it. If you are perpendicular to the slope, meaning rotated by 80 degrees, you don't need this lower generator CTR. Use a 5mm Allen key for the fastenings with a tightening torque of 10 Newton meters. We generally start at the bottom of the generator. We install the first row and align it properly with the outer fastenings. In the middle of the rail, about 30 centimeters from the end of the rail, you'll have your module frame. Not the fastening, but the frame of the module. The lower generator CTR, if you are aligned with the slope, goes against the outer fastening. Tightening torque for the CTR is between 2.53 newtons and 2.53 newtons for the fastening. Use a 5mm Allen key, tightening torque 10 Newton meters. At the top of the generator, you have the same outer fastening, but you don't need the CTR. Do not step on the modules. Tighten using screwdrivers. Impact drivers are prohibited. Tightening torque is 10 Newton meters, and you have the clip that allows you to ground 2 modules. And now we will look at installing the modules inclined at 10 degrees with the different parts for the tilt. And you'll see some parts we've already covered earlier for the flat mounting of the modules. We'll start with the parts we already know, the CTR for grounding. We also have the CTR for securing the outer fastener at the bottom of the array. The cable gland is available. As a valuable option, especially if you also specifically require the powerful optimizer and Then we carefully position and securely attach the main upper support piece, ensuring it is perfectly aligned and firmly in place for optimal stability. So here, it's equipped with the intermodule fastener, and you can find the outer fastener at the beginning and end of your array. And to tilt your module, you also need a lower support to achieve a 10-degree tilt. And just like when installing the modules flat, there's a measurement to check before clipping in our different parts. It's the 1040mm measurement, which is found between 2 rails under the modules, with a tolerance of plus or minus 1 centimeter. The other measurements, just like for flat installation, will depend on the size of your module. With the 10-degree tilt, you can have either a single shed or a double shed. The measurements for each option are indicated on every plan according to your module. You will also need to check whether the patches have been placed on the correct side, and most importantly, make sure they haven't been forgotten on either side of the rail. And just like with the flat installation of the modules, you always start with grounding, just as you do for flat mounting. Be careful with the well-known CTR. When you pass the green-yellow wire here, make sure the end does not touch the aluminum. And of course, we always use a tightening torque between 2.5 and 3 newtons, whether it's for tightening to the rail or for tightening the green-yellow wire. And with the complete systems for the inclined parts, you will typically receive them carefully packaged in sturdy boxes. And there's a specific, well-thought-out technique to effectively prevent everything from inadvertently falling apart or becoming dislodged when you meticulously take them out of their protective packaging, the box itself. Whether it's the essential lower support component or the crucial upper support element, the entire assembly ultimately comes together seamlessly and securely. And when you carefully take it out of the box, equipped with either the external mounting or the intermodule mounting, you absolutely need to hold it perfectly flat like this or keep it very steady and secure. Because if you happen to pick it up in the wrong way, what can potentially happen is that the entire assembly could easily come completely apart if it spreads open too much. Even the mounting can come off completely, but to put them back is very simple. For the mounting or the inter-module mounting, you need to slide the nut into the slot. Then the rectangular aluminum frame here slides into the bracket and you just slide it in. No matter which direction, whether it's the upper or lower rail support, the direction doesn't matter. You slide it in and it holds, but make sure you keep it in the correct orientation. Another important thing is that for the 10-degree tilt, there is only one direction, meaning you can't go from left to right, but only tilt to one side. For example, if you're flat and you tilt here, your small support on the left must be tilted in the same direction. That's just a quick reminder. There's only one way to tilt your supports. The mounting, when flat, is equipped with a clip, so your module frame is grounded, and there's this clip on your rail as well for snapping in, which we'll see on the screen in a moment. For your mountings, whether lower or upper, there's only one tilt direction. So if you tilt your module to the left, you'll know your small support is there and your large one is there. It's always based on the plan, only one direction for clipping. We'll use the large one, but it's exactly the same for the small one. You have a closed side of the support and an open side, and the open side is always for the nut. So always put the nut side against the rail. For the small one, closed side, open side, always nut side against the rail, and you install it. So the tilt is in the same direction, and the screw head is always on the same side, and the nut is always on the same side. To help yourself, you can create a 25 centimeter square. Your rail is 60 centimeters. Your mounting is 10 centimeters, so 25 and 25 on each side, and you're 10 centimeters in the middle. So if you create a square well aligned with your rail here at 25 centimeters, you'll know you're at the right distance, and you can run a string between your first and last mounting or in the middle of the array, depending on the size of your array. Take a maximum of 20 meters. This will help you align your supports. Tighten with a 5 mm Allen key to 6 Newton meters. Another technique would be to slide the support onto the lower support, but the clipping works very well. Here's a quick reminder. It's 150 millimeters. Module installation is always done by 2 people. When you install your modules, make sure to respect the tightening torque and the mounting, and keep a gap of plus or minus 105 millimeters in the direction of the tilt, and keep the squareness of your upper support. Sometimes you might press on the upper support and unbalance it, which puts extra stress on our rails. We're showing it here with a small module, but always present it with 2 people, because as you can see, it takes force. I'm not strong enough here, but it can make a difference. You must also respect the 90-degree angle between the rail and the support. Another thing to respect is the overhang of your module. Your module here, which extends beyond the upper support and the axis of the mounting. Whether it's the lower support and the axis of the mounting, the lower and upper overhangs must be identical, which I'll show you on the screen in a moment. These are the axes here of the upper and lower mountings, which should be around 105 centimeters, just like for flat modules. Impact drivers are not allowed. Do not step on the modules, and tighten your mountings to 10 Newton meters with a 5 mm Allen key. You can also use a string to align your modules and check your upper and lower overhangs. In general, on our plans, we indicate the gap between the bottom and top of the modules. It's around 40 millimeters. Don't hesitate during this presentation to visit our website to download manuals, technical approvals, and other documents. Register to be able to download all these documents. You can also check if the modules are compatible with your project. And if you have any questions after this presentation, don't hesitate to send your requests to the address shown here. If you have an ongoing project, please indicate it by starting with F or E, depending on the file. I wish you a great start to your project. Goodbye.